So 2.6 is called combining functions. We're going to determine the composite of two functions, and we are going to be finding the domain. Okay, so once you write that down, I want you to start thinking about domain. And whenever we're trying to find the domain, what are we looking for? Where are the restrictions? Okay, so the composite of two functions, you can look in that information box below and see that that is going to be your f of g of x is how we say that. So you might remember that from your Algebra 2 days. Okay, this is called the composite function f of g, or the composition of f and g. And the way that we say that is f of g of x. And the reason why I make a point to say that is so that you don't think it's multiplication. Okay, you are not multiplying this by x. This is a substitution. So when you see this f of g, it's the same thing as f of g is the same thing as f of g of x. And what this means is we are going to substitute g of x, which is going to be an expression. So we're going to substitute a full expression into an expression. Okay, so we're going to substitute g of x into f of x for the x variable. Okay, so these are the same thing. F of g is equivalent to f of g of x. So we're going to do that substitution here. Okay, so we are given f of x is equal to x squared, and g of x is equal to x minus 4. We're going to find f of g and its domain. Okay, so if you would like to, until we get more comfortable, if you want to think of this as f of g of x, you can. Because if you substitute in your g of x, it's f of, and then g of x is x minus 4. Yesterday we were finding values like f of a, right? Or in the past we've done f of the a plus h. So we have inserted expressions into other expressions before. What I like to do is take whatever's on the outside, this f of x, and if it's x squared, I know I just have to substitute x minus 4 in for x, and then I'm going to use algebra to simplify. Okay, remember that x minus 4 squared really means x minus 4 times x minus 4. So you aren't going to just square each term, you do have to FOIL that out. So x times x is x squared, negative 4x and negative 4x is negative 8x, and then negative 4 times negative 4 is positive 16. Okay, so this is your f of g. Okay, so earlier I asked you to think about the domain, and when we're trying to find the domain, what are we looking for in the expression? Where are some places where the domain is going to be restricted? Yeah, exactly. So you want to look for fractions. If there's no fractions, which there are none here, if there are no even roots, oops, I put no even. No even roots, okay, then that means there's no restrictions, and no restrictions means all real numbers. Okay, so your domain would be all real numbers. We are going to be writing these in interval notation today. That's how it will be on your assessment, so we're going to practice that. All right, so that was f of g and its domain. For b, we just have to find g of f of 3. Okay, so there are a couple different ways to do this. What I think is the quickest is to think of this as g of f of 3, where you can see f of 3 on the inside there. So if you start from the inside, your first step would be to find f of 3, which we can do very quickly, right? F of 3 is going to be 3 squared. X squared is 3 squared, okay, which is 9. And then your second step, once you know this is 9, you just substitute it, right? So your second step would be to find g of 9. Okay, so you're just doing substitution. Okay, and then if you find g of 9, g of x is x minus 4. So instead of x minus 4, you're going to plug in 9. 9 minus 4 is 5. That is going to be your final answer. Okay, so g of f of 3 is going to be 5. Okay, and then when you're doing that on your own, like I said, it'll be really quick. Like for step 1, you'll know it's 3 squared. Okay, and then you'll plug in 9, that'll be 5. Okay, so based on that, do you guys think you can do the 2 steps for C, which is f of negative 1? So we're going to start with the inside. Okay, so when you start with the inside, when you're writing this out, just remember, when you're plugging this in, you should have the negative 1 in parentheses. I see some of you don't have that notation correct, even though you did get the correct answer. If you don't put that in parentheses, your answer would technically be negative 1, okay, but we know negative 1 squared is going to be positive 1. And then step 2 is we're going to substitute that into the outside. And f of 1 is going to be 1. Okay, so I just want to show you, your work can be as simple as this. Okay, you do need to show your work, okay, for how you're getting your values. All right, any questions on page 1? That's step 1 and step 2. Okay, all right, and then if you wanted to as well, you could do g of f of x and then plug in 3. You could find f of x and then plug in negative 1. That would be fine. Okay, we're going to practice finding those different expressions. So in example 2, it says we're going to find f of g, g of f of f, and g of g in their domains. Okay, so we're going to find all of those in the domains. We're going to write the domain in interval notation. Okay, and then I recommend you do that on your homework too, since that is what you will be assessed on. So we have to find 4 things: f of g, g of f, f of f, and g of g. Okay, so for part A, you are given f of x equals the square root of x, and g of x equals root 4 minus x. Okay, so for f of g, okay, remember this is the same thing as f of g of x. So you are going to substitute g of x into f of x. So this is f of the square root of 4 minus x. You don't have to write that second step out. In fact, I'm going to stop writing it out after this one. And then your f of x is the square root of x. So what you're going to do is you're just going to plug in the square root of 4 minus x. This is f of g. So you're substituting this into your square root of x here. Now this is a special property that we talked about in chapter 1. Do you guys remember what happens with the root within a root? Yeah, you multiply the what? The index number. So 2 times 2 would be 4. So your final answer here is just going to be the fourth root of 4 minus x. Okay, this is your f of g. Great. All right, and now we go to the domain. So I don't have a fraction, but I do have an even root. So anytime you have an even root, we should remember from before that the radicand is what you set greater than or equal to 0. Okay, you're going to notice a lot of things that we talked about before are coming back in. So hopefully when we see them, we recognize them. So we're going to have 4 minus x is greater than or equal to 0. There are cases where you might have to make a table. Like if that was 4 minus x squared, it would be quadratic. We make a table. This is linear, so we don't have to do that. So I would just move the x over, and then you don't have to worry about dividing by a negative. Okay, so then this is going to be x is less than or equal to 4. When you're writing that in interval notation, if you want to do a number line so you can have that visual, that is fine. And then your domain is just going to be negative infinity to 4. And then because you have the equal to, it will include it. So you're going to have a bracket there. So this is your domain for f of g. Okay, any questions on that part? The f of g? Okay, and then let's go to the g of f. Okay, and feel free, like if I'm going a little slow and you remember some of this stuff, you can always pop to the next one. Okay, so for g of f, whatever's on the outside is going to be my structure. So this is going to be 4 minus, and then instead of the x, I'm going to do my substitution. So my f of x is root x. Okay, now for this, you have a root within a root, but it's different than this because here you have this 4 minus on the outside, so you do not simplify this. Okay, this is going to be your final answer. You cannot simplify. You can only simplify if the root is right on top of the other one and there's nothing added or subtracted to the outside. Okay? And remember, another way to think of these is like 1/2. The reason why we can do it here is if you have 4 minus, if you have 4 minus your value to the 1/2 power and that is to the 1/2 power, you can multiply those together, okay, and you're able to simplify the 1/2 to the 1/2. You multiply those together. For this would be 4 minus x to the 1/2. That whole thing would be 1/2, and you wouldn't distribute here, okay? You can't distribute when you have the minus. That's why it is not going to simplify. But we can do our domain. So for the domain, You have two different roots here. When you have a root within a root, you have to find the domain for each. Okay, so you have to do the domain for the square root of x, and it also has to be for the square root of 4 minus root x. Okay, you have to do the domain for each one of those cases. So for this square root, the square root of x, we know the radicand just has to be greater than or equal to 0. Bless you. Okay, so we know x has to be greater than or equal to 0. For this one, the radicand is 4 minus root x, and that has to be greater than or equal to 0. Yeah, like this part here. And then even though this isn't linear, you can solve this by adding root x to both sides. Okay, and then squaring both sides. Okay, so to undo the square root, we would square both sides. We'd have 16 is greater than or equal to x. And then because you have to satisfy both of these conditions, you have to find all the values that occur in both of these intervals. Okay, so you want all the numbers that appear in this interval as well as all the numbers that appear in this interval. Okay, so some of you can do that without a number line, that's fine. You can also use your number line. So it has to be this and x is less than or equal to 16. And if you use your number line, all you have to do is find where they overlap. So it's similar to the union symbol, the upside down U. So you're finding all the values where x is greater than or equal to 0, also less than or equal to 16. Okay, so your overlap is here from 0 to 16. And you can see you have the closed circles. So this is going to be your domain. Remember, the domain means these are the values that you can plug in to get a real answer. Okay, so if you wanted to check, if you plugged in any numbers in between, you would have a real number. Okay, anything larger than that is going to give you a negative underneath the radical, and that would be a problem, right? Because if I went less than 0, -1, can't take the square root, you'd have imaginary numbers. Okay, if I went higher than 16, I'd probably do 25, so it's nice and beautiful. But the square root of 25 would be 5, 4 minus 5 would be a negative. You wouldn't have a real answer there. Okay? All right. Let's do f of f. Okay, so feel free to try that. You can also do the G of G in your domain. Okay, so if f of x is the square root of x, we're going to do the square root and then the square root of x. So again, you have here a square root on top of another square root, so it's just the 4th root of x. Okay, that is your f of f. So when you're doing the domain, whatever's inside has to be greater than or equal to 0. If we write that in interval form, we have 0 to positive infinity. That's your domain for f of f. All right, and then we're going to do g of g. Okay, so for our g of g, we have the square root of 4 minus, and then we're going to plug in g of x for x, which is the square root of 4 minus x. Okay, again, you cannot simplify that. You don't have the root just within a root. You have that 4 minus there, so you're going to leave it. So anytime you have two radicals, you have to do the domain for each. Okay, so you'll have the domain for the root of 4 minus x and for the whole root, 4 minus root 4 minus x. Okay, and again, because it's an and, you have to find the overlap between those. It has to satisfy both conditions there. Okay, so let's set up our inequalities. So we know with an even root, we can't take the even root of a negative, so we're setting it greater than or equal to 0. Again, I would just add that to avoid having to divide by a negative. And then the radicand here is just the 4 minus the root. So notice I'm taking what's under the root, setting that greater than or equal to 0. I'm taking what's under that root, setting it greater than or equal to 0. Okay, so if I add over the root of 4 minus x, whenever you have a square root, you can square both sides once you've isolated the radical. And you have 16 is greater than or equal to 4 minus x. Okay, if you do subtract 4 from this side and you're left with the negative, just remember that you want to flip that sign whenever you divide by a negative. Okay, so I have negative 12 and I have 4. So all the values have to be less than or equal to 4 or greater than or equal to 12. So I can see where that overlap is. Again, you don't have to write out your number line. Just visually, I think it helps so you can see this is where both conditions are being satisfied. So negative 12 to 4. All right, and then for B, we're going to work with some fractions here. So f of x equals 1 over x. G of x equals 2x plus 4. Okay, so why don't you try f of g? Let's see if we can do the formula. All right, let's make sure we did this right. So f is on the outside, so it's 1 over x, but instead of x, I'm plugging in g of x, which is 2x plus 4. Nothing to simplify there. Okay, so this is going to be your expression. And then we know with the domain, besides even roots, if there's a fraction, we know there's going to be a restriction because the denominator cannot be 0. So if I set 2x plus 4 equal to 0, move over the 4, that becomes negative, divide by 2. So x can't be negative 2. So then when you write your domain, it's negative infinity to negative 2 in union with negative 2 to infinity. Okay, so you have those two intervals. All right, I'm going to help you with g of f so you can see how it should be simplified. Because like I said, there are different cases where people will get confused how far you need to simplify. So if I start with g of x, it's 2x plus 4. And then what you're plugging in for x is f of x, so 1 over x. So we do have to simplify this. So you're going to have 2 over x plus 4. And then what we want to do is get one term. Okay, so you're going to get the LCD to simplify. So if you have a fraction with x in the denominator, it's a number, it doesn't matter, it's just a constant, okay? But for x, that means it's going to be a rational expression, and so we want one factor on the top, one on the bottom. So we're going to multiply to get the LCD. So we're going to multiply by x over x. Okay, so then I'll have, think of this as over 1, then I'll have 2 plus 4x all over x. You can leave your answer like that because now you have one expression on the top, you have one expression on the bottom, or if you wanted to write it as 4x plus 2 over x, that is fine. Okay, so either of those would be great. And then when you have a fraction, you know that the denominator can't be 0. So here and here, both of these in both of the denominators, x can't be 0. So you would write your domain as negative infinity to 0 in union with 0 to infinity.
There's an interruption. Students, if you're going to bring a guest to homecoming that does not go to Hazlet High School, a guest form has to be completed. Since no one looked at the TVs in Four Corners, it was due last Friday.
Oh, okay, let's go back to this. So we're gonna try our, we finished g of f, it can't be 0, so negative infinity to 0 in union with 0 to infinity. Okay, and then let's do f of f. Do you guys want to try that on your own first? Do you guys want to read the TVs? So f of f. Okay, so you have 1 over x, but what we're plugging in for x is 1 over x. So can you guys simplify that for me? Keep change flip. Flip change keep. And then also like with the, with your g of f, like in one of my earlier hours, they asked me, oh, well, can you divide each of them by x? Well, yeah, but then you'd be back here, right? So you want to keep it like this. If there's a GCF, you don't have to take that out, okay? You're going to leave it. This will be your simplest form. All right, and then when you did keep, change, flip, you have 1 times x, which is just x, okay? That is your f of f. Now, when you have fractions, what you have to be mindful of is if they simplify here, this is not going to give you what your true domain is. So whenever you have fractions, you have to check the first step and the last step. Because if you look here, okay, we know that with the domain, that your x value could not be 0. And if it was, you wouldn't even be able to simplify to get to this final step. Okay, so you have to exclude that from your domain. So it's similar to saying, oh, here x has to be 0. For this one, it's all real numbers. So you have to find both. If it's all real numbers and x can't be 0, then when you're writing your domain, it has to exclude your 0. Okay, so you have to take both of those into account. And again, that is for fractions. So a good rule of thumb is with the fractions, you're going to check the first step, which is where you do the input or the substitution, and the last step. Because sometimes you might have a different fraction in your last step and you'll have to check that too. Okay, so there's many different situations for this. We want to make sure we get our practice in, so we see some different ones here. Okay, and then the last thing is we are going to do the g of g. Okay, so we're plugging g into g. So one thing I find helpful is instead of writing 2x plus 4, I usually write parentheses, and then I will go back and put in the 2x plus 4. Okay, so if you find yourself getting confused, that is a strategy you can use to help. And then we just have to remember our algebraic rules, our orders of operation, our distributive property here. We now have 4x plus 8 plus 4. You do need to combine your like terms. So 8 and 4 are going to make 12. Okay, and nowhere in there do we have a fraction. Nowhere in there do we have an even root, which means your domain is just going to be, if you don't have those, what's your domain? All real numbers. Okay, and with the roots, it's only the even root. So if you have an odd root, there's no restriction. If there's no restriction, all real numbers. Okay, so I'm going to give you time to work on your assignment. Okay, this is on page 196. This is 41 and 44, so I'm just going to put a comma. So don't do through 44, it's just 41 and 44. Okay, and again, you do have to show your work, so you have to show, like sometimes your work is going to be minimal, like if you plug it in and you don't simplify. Okay, and then I will also post answers for you so you guys can check those.